Hello everyone. In this video we are going to look at something interesting, a part of Simulink that we have not explored so far, and that is state flow. So state flow is a part of Simulink where you can basically do logic control. You can have very complicated logics for control of something or reacting to something. And yes, you can do that with simple ifs or simple MATLAB functions. But remember, the main goal of Simulink is what? Is pictorial presentation. So you can see what you're doing instead of just looking at a bunch of code. You can see the diagrams, you can see what leads to what and so on, and you can understand it better and hopefully debug it better. So the goal of Stateflow is that. So Stateflow is kind of a pictorial presentation of the system logic, and depending on where the system is, in what state it is, in what situation it is, what kind of decisions to make, what kind of actions to take. Okay, and as we'll see, it's very good. It's like a block diagram system with wires and states, and you see transition between the states, and it's very easy to see, very easy to debug and understand. So it's really good for, as I said, logic control for systems that are event-based, right? So if some event happens, you need to do something, okay? For systems that have to react in real time or during some operations. So it gives you all of that. It's a really powerful part of Simulink, and I'm gonna talk about this in a few videos. So I cannot cover it in one video. So this video, you can consider it like a Stateflow intro or basics of Stateflow, right? Or video 1. And then hopefully I add at least 2 more videos to talk about more advanced topics in Stateflow. So how do we make a Stateflow? So if you go to library, right? And first, let's say, make a new file. Now I'm going to show you what I have here for you today. But if you create a new blank model, right? So here, you create a blank model like this, and you go to the library. You can use regular Simulink blocks, and also if you go down here, you see that we have what? We have Stateflow. And under Stateflow, there are 4 major blocks. There is a chart, there is a sequence viewer, truth table, and state transition table. And what we're going to work with in this video is simply chart. We're going to use a chart, which involves basically states and the transition between the states, and you can go inside the chart. Once you go inside the chart, now you have a bunch of tools on this left-hand side, as you can see. And these tools can give you a bunch of important things. Like, for instance, this is the most important one, probably, the state, right? So you can drag a state, and I'll show you how to add the state name, how to add basically actions for it, and so on, right? So this is the state, right? And then, as I said, there are other things to it. There is junction, there is the default transition, there is box, there is this Simulink state, there is Simulink function, there is graphical function. There are lots of tools, MATLAB function, truth table, history of junction, exit, entry, and so on and so forth. So there are lots of things here that we're going to explore throughout the videos. And on the right side, you also have your property inspector, which talks about the solution and so on. Okay, so what is it that I want to do in today's video is, here, let's say I have a 2DOF planar arm like this, and I want some logic for how to move these 2 joints, Q1 and Q2. So let's say my logic is this. My logic is if, let me add an annotation. So here you have annotation, and you can add a picture. That's how I added that. So let's say here, my logic is this, that if the switch is on, and this is my switch, this is a toggle switch which I got from under dashboard, right? So if you go to Simulink, you should have dashboard here, and this is basically this toggle switch here, and I'll show you. So if the switch is on, if a robot switch is on, and angle theta 1 or Q1 in this case, doesn't matter, Q1 or theta 1, they're the same thing here. If this is less than 1.2 radians, I want motor 1 must be turned on and stay on, right? And let me use a larger font size. Okay, so this is the logic that I want to implement. So if the robot switch is on and the Q1 is less than 1 point on, motor 1 must be turned on. Now, if theta 1 is what? Bigger than 0.8, so while theta 1 is starting from 0 and going to 1.2, at some point it passes 0.8. At that point, turn motor 2 on as well. Okay, yes? Then, when theta 1 goes bigger than or equal 1.2, turn motor 1 off. Now theta 1 reached wherever it should reach, so turn it off. Theta 2 keeps going on until when theta 2 becomes bigger than or equal 0.8, and this is in radians. Now turn motor 2 off as well. Yes, so you see, we want this logic. So we start with both motors off, right? And let's add something here. So starting from both motors off, if the robot is switched on and Q1 is 1.2 radians, motor 1 must be turned on. Then if theta 1 passes 0.8, now it's time for motor 2 to go turn on. When theta 1 passes 1.2, now you turn the motor 1 off because it reached wherever it should reach. Now when theta 2 passes 0.8, turn motor 2 off too. And whenever during operation motor switch or robot switch is turned off, turn both motors off. You see? So anytime that the operator, that's like your, you can call it like an emergency stop too. So anytime that this switch, this toggle switch is turned off, it doesn't matter where I am, how much is angle 1 or angle 2, you have to turn both of these motors off. So angles theta 1 and theta 2 should not change after that point, because the switch, which is kind of also acts like an emergency stop, this is going to be what? This is going to be turned off. So this is what I have, and I want to do that as well. And yes, again, I can use Simulink blocks of if and if action and so on and do it, but that does not show me which part of the system is activated, which one is not. It doesn't show me if something is failing or not. So this Stateflow is amazing for that purpose. So what did I do here? I brought in this constant block, which takes a value of 1 or 0, and then I connected it to this toggle. So you see here that constant value is connected to this toggle. When I turn it on, it gives me a constant of 1. When I turn it off, it gives me a constant of what? 0. Okay, you see that here? Right? So that is turning the motor, that's the robot switch, on and off. Now, what do I have inside this state? So what did I do next? Once I have this one and this one, then I brought in from Stateflow, I brought in a chart. like this, and then I went inside of it, and then I created some states and some transitions, which I'm about to explain to you. Those will give me a control of whether motor 1 is on or whether motor 2 is on. If motor 1 is on, I send that on signal to here, and I multiply that value of 1 by some constant. This basically controls the speed of the turning, and I integrate that speed, and it gives me the angle, right? So this is kind of like your omega, right? This is omega 1, whether it's on or off. This is the actual omega 1, right? This is the omega 1 gain. And a similar thing for omega 2. The only reason I use them here, I just want to control how fast these angles go up, right? So here, those are like your omegas. They give the control to omegas to be integrated into thetas. And I put both thetas here side by side in this scope so we can see it. Now, let's see what I have inside this chart. So this is the motor control chart. I go inside and I want to explain what is going on here. So in this situation, there are only 4 scenarios possible. Either both motors are off. You can see that this is the first state of the system. Motors 1 and 2 off, underscore off. Or they are both on here. Or motor 1 on, underscore motor 2 off, right? And let me get rid of that. Or what? Motor 1 off, motor 2 on. Yes? So it's one of these 4 scenarios because you have 2 motors. Each one can be on or off, so you only have 4 total states. So here, I grab this state, I bring it in, and then you see here, I can type in a name. So here, the name is what? Something like, for instance, motor 1 on, and I'm just replicating these basically for you, and I'm using a different name so it doesn't have any conflict with that. And then what? Motor 2 off, something like that. You see? So you give that state a name. The next thing that a state can have is what? Is basically the actions for it. So each state has some name, as you just saw, and then what? It has some actions. Now, what kind of actions can you take with a state? If the system is inside the state, what kind of actions can you take? Here, if you look at the MATLAB help, you see that a state can have 3 types of actions: entry actions, during actions, and exit actions. Entry actions happens when the system transitioned or changed or come into this state, whatever it is. Here, state A. So as soon as the system switches to state A, this action happens. Okay? And as long as the system stays inside A, I can have another one which is called during. And during that the system is inside the state A, I can have some action. And when I want to exit that state, again, I can have another action. You see, so I have entry, during, and exit. And these are very powerful because in Simulink, what you typically have is only during, right? So during something happening, you do some action. That is what you do in Simulink. But when the system just enters a state or exits the states, Simulink does not really give you much of control over that unless you add a lot of more blocks. Okay, like a stop block or something, or action block. So here you can combine all of those into one single state. This state allowing you to do lots of different things. Okay, so this is very important for control. Because in control of complicated systems and equipment and machinery, some operations has to be taken during being in a state. Some has to be done when you're just entering it one time. And some operations have to be done when you're exiting that one time. Okay? And here it gives you all of those capabilities. Now, here for the sake of this video, all I'm going to do is to just create an entry function. So as soon as my system enters a state, I want to take some actions, okay? And I want to show you how I do that. So what I do is right after this, right, I type the name of the system. Now I say entry, column, and now I can do whatever action I want. I can set any variable, I can activate any signal or anything I want. Now, what is it that I want here? I want this chart to communicate with Simulink. So if you look at this chart, it has 3 inputs: robot switch on, theta 1 and theta 2, which are feedback from the robot, and then it has 2 outputs, motor 1 on and motor 2 on. So when you bring a chart into a Simulink, it does not have any input or output, right? It does not have any port, entry port or exit port. But if you want, you can add those to the chart. How? So when you go inside the chart, you can grab a state, as I showed you. You can give it some name and you can define some actions, right? Like that. But also you can what? You can communicate with outside of this chart by ports. How? You right click here and then you go to this one, says add inputs and outputs. And now you can get your data input from Simulink. These are your input ports. You can send some signal from here to Simulink. This is your output to Simulink. You can have messages and you can have events. And we'll talk about messages and events later. So right now, let's say I want to get something from Simulink. So I create an input here. And what is it? Let's say I want the theta 1 to come into this chart so I can do something with it. You see the scope of it is input, not output, not parameter, not constant. You can add all of those, not a memory or a local. And you can provide size. If you don't know the size, you can leave it as -1, so it's inherited. And you can give it a port number here, right? So there are lots of things. The type is, you see here, inherit from Simulink. You can change the type of it if you want. And now look, you see here, you see, now I have an input port theta 1. So now I can connect this to what? To some signal theta 1. Or if I go back, I right click and go back again, output to Simulink. This one is, I don't know, motor on or something. Let's say I have a signal called motor on. And this is an output this time, right? And it's port 1 output. And I OK that. Now look, you see here. So now you have what? You have this output to Simulink called motor on. So here you can create this input and output ports. Yes? And this is exactly what I did inside this chart. I created 3 signals, as I said, for input. 1, the switch. The 2 are the theta 1 and theta 2, so I can run my logic. And the 2 outputs are the signals on and off really to the motors. Okay? So this is my chart, and as I said, there are 4 states in this system. That both motors are off, both motors are on, 1 is on, 2 is off, 2 is off, 2 is on, 1 is off. And you see, in the scenario that they are both off, I say motor 1 on and motor 2 on, their values are both 0, so they are both off. When they are both on, then they are both 1. And then here, 1 is 1, 1 is 0. Yes? Now, the important thing is, how would you go from one state to the other? The transition. How would you do the transitions? Here is where you add these arrows. These arrows and the conditions above these arrows are what makes the transition possible. So first, let me show you here, and then we go and explain that. So let me say I have another state here like that. Okay, and this is called state 2 with some entry action, x equals 5, let's say, semicolon. And this is state 1. And here, again, the entry action is x equals 0 or something, right? Now, let me get rid of that. I'll explain that. So if I want to go from state 1 to state 2, what can I do? I just bring my mouse to the wall of state 1, hold down the left mouse key and drag, and boom, here I connected them. If I want to have a transition back, again, I bring my mouse here, and then what? Here, I connect them. And they can be straight line and they can be curved. So if you move this guy up, you see, you can get them curved. So they don't need to be straight lines, right? Now we can provide some condition here. You click on this line, go to this question mark, and inside what? Inside the braces, you provide conditions. If you want, you can take some actions too during the transition. So during the transition, you can take some actions too, or you can leave taking actions to go inside the state and then take a transition, then take an action, right? So you see in your transitions, you can also have some actions. So here, let's say I want to provide a condition. So my condition is when theta 1 is bigger than 2, right? Do this. Here is when my theta 1 is bigger than 5, then do this one. And I can grab these conditions and I can move them anywhere I want along this line or curved arrow. Yeah, so you see, now I made the transitions possible. Okay, going back, and the good thing is this, since theta 1 is an input to this chart, I can use it anywhere here. I can use it in my conditions, I can use it in my anywhere inside this if I create a functions, which I'm about to show you. In those functions you can use this theta 1 because now this chart recognizes theta 1. Theta 1 is what? One of the parameters this guy can recognize. Now, one other thing you have to do with the states is what we call a default transition. When the system is turned on by the switch, which one of the states is the one that the system starts with? You cannot leave the system up in the air with several states without the system knowing which one to start with, which one is the default. So you need to use this arrow, which is called default transition, and put it on the one that is by default active. So in the case of the motors, I want my motors to be off unless something happening, right? So I grab this guy and what? Drop it right onto that state. Look here. So I grab this and drop it on this. Now this is my default state. Okay, and you see, by the way, let me show you. Look, right before that, if you look around this state, there was a red. There is this red halo, and you see here, if you go there, click on it, it says default transition missing. So this Stateflow is like MATLAB code. It's very smart. If there is an arrow, you see a red halo around them. If there is a warning, you see a yellow or orange halo around these states. Okay, so it tells you something is missing, or it gives you some error or warning down here, some diagnostics. So here I drop a default transition here, and it knows that it has to start with the state 1. Yeah? Okay, so here I dropped it on the case that both motors are off. And now what? I can go ahead and start with both motors off, and then immediately look into what? Look into robot switch on. So now look at how I did these conditions here. How do I go from both off to only motor 1 on and 2 off? How? When do I turn on motor 1? Here I say when the robot switch on, remember robot switch is either 0 or 1, it's a logical value. So when it's 1, basically, when the switch is on, and what? You see I can combine conditions here. And theta 1 is less than 1.2. So as long as it's less than 1.2 theta 1 and switch is on, which is basically this condition here, this line, right? It's exactly this line in red. That is that first transition that I made. Okay, and here it says starting from both motors off. Look at that. That is what? That is your default condition. Remember, you have a default condition, that's this orange one. Then what happens? when your theta 1 passes 0.8, you have to turn motor 2 on, right? And this is this guy here. Look, the motor 1 was on, but now that the switch is on and theta 1 passes 0.8, it's time to switch to this state where both of them are on, which basically means turning motor 2 on, right? So that is this guy here. Then what? Now, when theta 1 passes 1.2, now I have to turn motor 1 off, right? So let's go and look back. That is what? That is this guy here. The switch is still on, but theta 1 passes 1.2. Now I have to go to this scenario where motor 1 is 0, motor 2 is 1. That means turning motor 1 off. And finally, what? When theta 2 passes 0.8, it is time to, what? It is time to turn motor 2 off too, and that is what? That is this scenario here. Look, this one. Switch is still on, motor 2 control. Now here, instead of providing a condition and saying theta 2, saying theta 2 bigger than 0.8, I did that using a function. I just want to show you how to implement a function, because this logic could be quite a bit more complicated. Right now, it's as simple as theta 2 bigger than 0.8, but it could be very complicated function to decide whether I should turn motor 2 off or not. So the way I did it, I used a function to make that decision for me. And that is this guy. And that function returns a 0 or a 1. 1 is, as you can see, when the angle it receives is less than 0.8. It's 1, means basically, 0. When the angle is less than 0.8, it gives you a 0, means don't do it, because this variable will be 0, this is going to be 1, the whole thing will be 0, so transition won't happen. When this condition is false, this path 2 is like your else, then return a 1. Now both of them will be on, so the transition does happen. So how do I implement this function? I'll show you. Okay, but here I want to show you how to use a function as well. And now you go what? You go to the off scenario, okay, which is this purple line. Now, before I show you the function, I want to talk about the last scenario, which is when the switch is turned off, make sure everything is off. So how do I do that? Well, here, this guy automatically goes to off when this robot switch on becomes a 0, which means you turn it off. This one automatically will transition to this default one, where both of them are off. But between this state and this one, there is no transition back to this unless I add them. And you see here I did that. I added this, and I said as long as not of robot switch on, which means that becomes a what? The robot switch becomes a 0, not of that is a 1, means the transition is going to happen. And I did a similar thing for what? For this guy back to here. I said for this one also, anytime the switch is turned off, go back to both motor off. You see, so I provided these 2 extra transitions. So now all three of my states can easily what? Can easily transition back to both motors off as long as that switch is turned off. Okay? So now let's talk about what? Let's talk about the function. How do I create a function? So there are different types of function. There is a MATLAB function and there is a graphical function. I want to show you the graphical one. So you grab a graphical function like that and you give it any name. The format is exactly like MATLAB. So function out equals my logic of in, right? So you have some input and it gives you an output with some logic. Yes? Now the question is, how would you write that logic? This logic could be very complicated. It could be a simple if-else, or if-else, or switch, or loops, or anything. How would you add those logics to your state flow? So here, if I right click here, right, and say add patterns in function, then you see I can add decision using ifs or nested ifs. I can add loops, right? Yes, or I can do switch, or I can select any pattern. So here I go ahead and say I want a decision, and it's a simple if else. Okay, and now it says, okay, describe that to me. And I said the description, you don't need to put a description. That's arbitrary. That's voluntary. You don't have to do it. You don't need to. But the if condition is like what? If, for instance, theta 1 is bigger than 5, right? What is the action? The action is the out equals 1, else is the out equals what? 0, and I can type in anything I want. So as long as theta 1 is bigger than 5, give a 1 to the out, set the output to 1, else make it 0. Look, once you do it, it adds that logic for you. And here, I make this bigger, so it includes everything that I have. Right? So now you can move the whole thing around. So now, instead of saying this condition, which is theta 1 bigger than 5 for this transition, I can say what? I can say my logic of theta 1. Look. So what happens? I pass my theta 1 to the function, let the function give me a 1 or a 0. And the function compares theta 1 first to which path? Which path does it go first? You see that with these numbers 1 and 2. First path 1 is checked. That's your top if. Right? If the top condition to be checked is against 5. If that is the case, then the output will be 0, done. If this condition is not satisfied, then it goes to path 2, where sets the what? Sets the output to 0. Yeah? So you see, here I can do this instead of saying theta 1. But the reason I do that is, in this case, it's not really needed, but when this function is very, very complicated, instead of typing a very, very complicated condition here, which might not be possible because you might need to do some loops or something here before making a decision, right? Then I can pass it to, as I said, I can use my function to make that decision. Okay, so, or I can use a code if I want to. And that code can take what? Can take in your theta 1 and give you this output. But instead of doing it graphical like this, you can do it what? You can basically type a code. You can directly type a code. You see here? So here I can say out equals my logic 2 of n, and then say if n is bigger than 5, then output equals 1, and else output equals 0, something like this. End. Okay, yeah, so now I go back. You see, I have this function, and with this function, you should be able to what? Basically take the input in and send the output. So here I can say my logic 2 instead. Right? Yeah? So you can do it with that one. These are your utility functions to make complicated decisions for you. So you use them in these transition conditions. So what I have here is a similar thing. And again, which one of these conditions here is checked first? These numbers 1 or 2 will tell you which one that is being checked first. Okay, so I showed you a simple MATLAB function, and the one I prefer is the graphical one, and I'll tell you why. But here we have seen this. You can do truth table to make your decisions or set up your inputs and outputs. So there are lots of things you can do, but we are not going to see all of that in this video. So here is my total logic, and now what? It is time to put it to the test. So let's get rid of this. And here I'm gonna double click on my scope, and I want to show you an interesting thing. So let me see if I can make this smaller. And I want to, if I can, zoom onto this area for you and show you this somewhere not on the way, like there. So now look at what I'm gonna do. I'm gonna run it, and what I want you to see is when I run this, the state that is the active state will be highlighted. That is one of the best things of Stateflow, that it highlights the state that is active, and it highlights the what? The transition that is active, and it also highlights the parts inside the function for you, the path that is active. So it's extremely good for debugging. So for that purpose, you know what, let me zoom into this guy. So I'm gonna move it a little bit off so I can show you side by side. This is really good. This is my favorite part of the Stateflow. Look what happens here. We run from beginning. Look. Do you see? Right now, that state is on. Look. You see, your angle theta 1 is going up until it reaches 0.8, then motor 2 will be on 2. Look. Here. Now, this one is active. It goes active until this guy goes to 1.2, then motor, you see this gun is going up. At 1.2, the motor 1 is going to go off. You come here. Here, you see? This one keeps going up until it reaches 0.8, then you transition back to both zeros. Look, here. You see? Now you're here and you stay here. Did you see that? How you started from here, you went here, you went here, you went here, and go back. Right? Let me show you one more time here. See how beautiful it is when it transitions and it highlights for you. And this guy will only basically be used one time, okay, during this transition. Look again, this goes up to 0.8 before this one becomes activated. Look, here we go. That transition became active. This guy came in. Now look, this is going up until this reaches 1.2. Then you switch to only motor 2 here. And now look at 0.8. At 0.8, you see here, look at here. Look, 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 look. Did you see it? Before 0.8, this one was always what? Called. Because now you have a theta 2 non-zero. So this one was active. Did you remember that? Did you see that? I'll play it for you one more time. This path was active, this path 1, because angle, which is theta 2, was less than 0.8. So this one was active, which is status 0. And as soon as you transition 0.8, this path became active. And this guy becomes 1, so you went back to the original one. Let's look at it one more time. It's worth looking at it one more time. And look, when theta 2 starts being non-zero, which is after 0.8 of theta 1, look, this function becomes active. Sorry, 1.2, not 8. Look, wait, here. Look, this path is active. Then in a fraction of a second, this one becomes active. There we go, you see it? And now they are back to 0. Now look, at any point, as I said, if I turn my switch off, so I go back here, at any point, if I click and turn the switch off, these two should not go up anymore. Look here, look. Your theta 1 is going up, look here, off, look. You see, it locked at that angle. Now I turn it on again. Look, here. You see, it keeps going up again because my switch is on. And here, even from outside the chart, you can see which state is active. Look, Now that one is active. They are both going up, but I stop the system again. Look here. You see? They are locked at their values. And which state is active? Both motors off because I turned them off. And again, I turn them on. Look here. You see? It keeps going. Again, I turn it off. You see here? Seems like, wait a second. Yeah, there we go, locked. So this one is doing its job, right? And here, since both angles already passed the value, you're going to stay at that, and you're not going to change. Okay, so this highlighting is one of the best things that it does for you to basically observe and debug. Now, one last thing I want to mention before I finish this video is, if this system becomes very complicated, if your system starts to become complicated, so many states, so many functions, some of them are independent from each other and they can run in parallel. So right now, this one is running on its own, but if you have another logic, another subset of the system that has its own logic, and this one and that one has to work in parallel. Let's say your system has two of these robots, right? Your system has two of these 2DOF robots, and each one has its own control logic with a separate chart, right, inside here. How could you organize this so you don't have a ton of states, transitions, and functions? Well, you can put these guys in a box, and basically, you see here, you can create a super state, or you can create a box to kind of hide this and make it more organized, okay? And we'll talk about the super state in the next video, but here you can create a box, or you can just comment it out. You can comment out a whole set of blocks if you want, so they don't work. So here I want to show you the box, which is kind of like a subsystem, kind of, not exactly, but I want to show you this box. So I create a box, and now look, everything is inside this box. You see? So if I have another one of that, I can have it as a separate box here, right? Yeah, so here, this is your box element. I can create another box, and I can put some logic inside this box as well if I want to, right? So here, look, this is my box. These are the information. And one thing I can do with this box is I can hide what's inside of it. Right now, you can see what's inside it. But if I want, I can hide it. How? So look here. If I right-click on this box, right, then you go here. It says Group and Subchart. Right now, there is nothing. But if I say make those elements subchart, means they should only be visible from inside the box, not outside. Look here, right? Now, if I come out, look from outside this chart, look, you see? Although there is stuff inside of it, there is no way for me I can see it. It's kind of like a black box right now. But if I go in, right, now I can double click on it, go inside of it, and I can modify it. From outside of it, inside the chart, you see, from outside the chart, you cannot see it. If you go inside the chart, you can see the content of the subchart. You cannot modify them. In order to modify them, you have to double click again, go inside the subchart, and now you can access them and modify them. Okay, so you can create subcharts if you want to. And I just wanted to explain that for you. And as I said, you can run these stuff in parallel or one after each other or something. And the way to do it, again, we're going to see it in the next video, but you right click here and you go to decomposition, and here you see here I can run exclusive or I can run parallel AND. Okay, so we talk about this advanced stuff in our future videos. Here, I just wanted to show you some basics of Stateflow. So stay tuned for my next video and hopefully another one where I can explain more advanced stuff. I give you a download link for this file if you want to download it and play with it. And I'll see you in the next video. Thank you.